The first couple, and I'll tell you this, and it'll be the same on the quiz tomorrow. I don't necessarily like how they write it, but it's the program on the computer that does it this way. They always put their I's at the end. So, like, for instance, on number 2, I'm going to break 28 up into -1 times 4 times 7. And I'm going to bring out the -1, and I'm going to bring out the 4. And if you want to do the tree diagram here, you can. Okay, this is the one where you have a couple of options. But this would be 2I radical 7. And that's how we have written it. Okay, and that's the way I would prefer to write it. But because this is multiple choice, they kind of treat the I as like a variable. I think it's just the way the program is written. And so they put the I at the end. Okay, so it's not under the radical, so it's still outside the radical, but it just happens to put it at the end. So C is the one that we want there. But anytime throughout this chapter that we see problems like that where we're simplifying an I, it's always going to put it after the radical. And I don't really like that, but that's the way it is. And so just so you know that as you go, okay? The other ones on that first page, you're doing a bunch of different operations with I's. So you have addition, you have subtraction, you have some multiplication problems, a little bit of everything. I will tell you this, just from years past, sometimes people see this and I'll see people trying to FOIL ones like this, okay? This is not a FOIL problem, this is just straight addition. So all you're doing here is combining like terms, okay? So it should be pretty straightforward. This one, we're just going to distribute the minus sign through and then simplify it. Remember ones like number 5 or 6, anything where you're multiplying, we're going to distribute in this case. So we have 72I minus 56I squared. And then I squared. You got to remember that I squared is always -1. We said that is the one thing. Anytime we have an I squared, we never want to leave our answer with that. Okay? And so we're going to make this a -1. And so this makes this 72I plus 56. Okay. And we always put the 56 first. So then that would be D. So just remember the I squared. I squared is always -1. Doing the same thing, 6, 7, and 8 are all FOIL problems. Make sure on number 8, when you see one like this, I would encourage you to write it out. 8 plus 2I times 8 plus 2I, and then FOIL it. Bless you. On number 9, the division ones, and there's only one of these, we're going to multiply by the conjugate of the bottom. And remember when we do the conjugate, we don't change the sign on the 2. We only change the sign in between the 2. So we have -2 minus 7i. And so then we'll have to FOIL on top and bottom and simplify it. So a little bit of work involved there, but just remember it's the conjugate of the bottom that we multiply on both top and bottom. Okay, on number 10, that's one of those I to the power ones that we talked about. Remember there's 4 that you have to remember, okay? And if you can remember these first 2, you can pretty much generate anything after this. I to the first is I, that's pretty straightforward, okay? I squared is -1, that's the one we always got to remember, okay? I to the third, remember I to the third is taking I squared times I to the first. So that's really taking -1 times I. So if you can get those first 2, you should be able to get all 4 of them here. I to the fourth would be I squared times I squared. So that would be -1 times -1, which is 1. Okay, and I'm not going to put those up on the board tomorrow. So you'll need to know how to regenerate those 4, okay? And then just continue the pattern. Remember, there's only a pattern of 4. So when I'm going to 14, I could just go 1, 2, 3, 4, 5, 6, 7, 8. Just count up to 14. We talked about a few other things you could do there, but just being able to regenerate those 4 would be what you need to do there. Hey, on number 11, it's already factored. Okay, so what I'm going to tell you here is just set both of those equal to 0. When it's already factored, 7x minus 4 equals 0, 7x plus 2 equals 0, and you just solve for x. Okay? Don't try to overthink it. Don't try to overdo it. Just set them equal to 0 and solve. Okay, on number 12, if it doesn't give you a specific method to solve by, you can use whatever method you want. What would be our go-to method? The first thing we should always check when we're solving a quadratic equation. Graph it. Okay, that would be my go-to. Okay, it doesn't take much time to plug it in. We can see where it crosses the x-axis, and if it tells me, and especially because it's multiple choice, okay? There's going to be some on here where I tell you to use a specific method, but on these where it just says solve, you can use whatever method you want. Okay, I'm not going to look for any specific order or anything like that. Okay, so that's what I would say on this one here is just graphing. That would be always my go-to. It'd be always my first thing I would look for. Okay, 13, just finding the zeros. Okay, once again, over and over again, we talk about quadratics. Here it crosses the x-axis twice, so those are my zeros, and those are my solutions. The x-intercepts, whatever you want to call it. Okay, there is one, and this one I do want you to show completing the square. Okay, I'm only going to ask you to do one of these. I probably won't put one of these on the test. Okay, but I do think it's important that we at least try it. So I put it on the quiz because if you don't do it right, you could correct it. Okay, but this one is a pretty straightforward completing the square one, and I know you can solve this one other ways. Okay, I know you can factor it. I know you can graph it. I know you can do those, but I will look for the steps for completing the square. To get full credit on that one, you'll have to complete the square. Okay. Okay, 15, quadratic formula. I'll put that on the board. That will be the one formula I will give you for tomorrow. By now, I would hope that a lot of us know it pretty close, but if not, you just need to be able to plug it in to your formula, okay? And so if it says use the quadratic formula, and I want you to show me using the quadratic formula, and whenever it says exact, we're going to leave our answers as an exact answer, okay? So we don't just want to put it into the calculator and get decimal answers. Exact means we're going to leave our answer with i's or radicals or whatever they might be. Okay, and usually on those ones that I ask you to do the quadratic formula on, they are ones where you're going to get an answer with a radical in it or an I in it. It's not just going to be like 5 and 2 for your 2 solutions. It'll be ones that have an answer that is a little bit different. Okay, on 16, you are not solving it. You're telling me how many solutions and what type. Okay, and you have 3 options here. If it's equal to 0, we have 1 real. If it's greater than 0, we have 2 real solutions. If it's less than 0, we have 2 imaginary solutions. So all you got to do is tell me what's the value of the discriminant. Always make sure, like on any of these solving ones or the discriminant problems or any of these, make sure your equation is always set equal to 0 first. If it's set, a lot of them will be already set equal to 0, but if it's not, we got to set it equal to 0. And then on this one, you just have to find out what the discriminant is. What's the value that goes underneath the radical? And that tells me how many solutions I'll have. 17, you can just put this one right into your calculator. It even says to solve graphically. So that just means put it in the calculator where it is across the x-axis. If you need help with your calculator, let me know today and I can help you with it if you don't remember how to find those zeros. We've already done that this year though, so I think most of you should be good on that. 18, you can use whatever method you want. I probably once again would go, anytime it doesn't tell me what method to use, the first thing I would always check is my calculator, okay? And especially because this one's multiple choice, then it should be pretty straightforward. And so that would be another one that you could just put right into your calculator. Okay, on the vertex, once again, you can use your calculator, okay? And what we're looking for here is the maximum or minimum. When we have a parabola, we're either going to have a minimum where it's the very low point of the graph, or we're going to have a maximum where it's the high point of the graph. One or the other. That max or min is my vertex. But I'm telling you max or minimum because, like, especially on the TI calculators, that's what you're going to have to use to find that vertex. And so once again, using your calculator is a great way to do that. Okay, axis of symmetry. There's a couple of different ways that you could do this. You could find the vertex, right? And the x value of the vertex is always my axis of symmetry. So if you wanted to do what you did on number 19, again, you could do that. Or you can do the negative b over 2a, the little formula there. I'm not going to give you that formula tomorrow, but here's a little trick to know, okay? If I cover up the discriminant part of the quadratic formula, negative b over 2a is your axis of symmetry, okay? So it's right there in the quadratic formula if you get rid of the discriminant part of it. So that's one little trick you can use. And you can figure out the axis of symmetry pretty quickly by doing negative b over 2a. If you want to, you can use your calculator. Okay, I'm okay with that too. On 21, just remember that the max or min value is the y value. And so you're, once again, it's just another situation where you're still finding the vertex, finding that maximum or minimum. But in this case, they're looking for the y value. That's why we always write it as like 8 at x equals 2 or whatever, because 8 is the maximum or minimum value. And it happens when x equals 2. But here, it's not writing it like that. It's just saying, what is that maximum value? Doesn't necessarily say when it happens. Okay, and then to finish up here, we just have some graphing problems like we did yesterday. All of the vertex stuff we did yesterday too, but number 22 should be pretty straightforward. You can put it into the calculator. You could also even remember some of the basic things like it's going to go left 3, it's going to go up 5, and then the negative out in front is going to flip it over. So you could just look at those changes, but probably not a bad idea to go ahead and put it in the calculator and then just kind of verify that it's where you think it's supposed to be. So that could be another calculator problem. Okay, on 23, we did a couple of these yesterday where we talked about increasing and decreasing. So we got to find out where that max and min is, and then we got to identify where is it increasing versus decreasing. If your graph opens up, it's decreasing here and it's increasing here. The vertex is where it changes direction. If your graph opens down, then it's increasing on the left and it's decreasing on the right. So it kind of depends on what type of parabola I have, as where is the increasing and decreasing happening. So that's really the only difference. It's based off the type of parabola you have. So be careful of that. And then we're just writing it in the interval notation, like we talked about yesterday. And then on the last one, number 24, tell me what the vertex is. It's going to be an ordered pair. Axis of symmetry is always going to be x equals something. But remember, it's always the x value of the vertex. And then I want you to show me a couple of points. Okay, and can I get those points off my calculator? Sure, why not, right? We talked about that yesterday. You have a tool to use that you can do a lot of this stuff. You just know how to use it. But I do want you to show me those points. I don't just want you to slap up a parabola on the graph and say, here's my parabola. Okay, I want it to go through the right points because we're trying to graph that specific function or equation, and so it has to have specific points on it. If you just throw a U up on the graph, then I could put a U anywhere, and it's not the right graph. Okay, so specific points. And so those are the three things that I would be looking for on one like that. When it says graph, we're looking for specific things about that graph. So that's why we want to graph it. Sometimes we're just looking at the shape of a graph and answering questions about it. Here, or the problem is graphing it. So we want to be pretty specific with our graph. You won't necessarily need to put anything on the blank right there. You're just going to graph it, give me a table of values, tell me the vertex and axis of symmetry. Okay. Any questions on any of that stuff so far? Okay. I'm going to let you guys work.